Hey everybody, we are going to be looking at lesson 6-3 today. Go ahead and grab a calculator because we're going to need it for all the lessons in this unit. So we're going to be applying the Pythagorean Theorem today. So we're not learning anything new as far as formulas, but we are going to have to use the Pythagorean Theorem and then maybe do some adding or subtracting or some thinking. So take it slow as we go through these. All right, so the first situation is we have Bethany, who has a circular tabletop that she needs to take inside of her house to paint. The front door is a rectangle with a width of 36 inches and a height of 80. The tabletop is 86 inches across. Will it fit through her front door? Well, before we even start where it says plan and work, I'm going to go ahead and draw my door there. I'm a picture person, and I have to do the picture first. Okay, so, oh, look how lovely my door is. Okay, there's the door. So I've got a rectangle there, and I know that my door is 80 inches high, 36 inches wide. The tabletop that I have has a diameter of 86 inches across. Okay, so what I know is that I can't carry it straight through because it's only 36 inches wide and the tabletop is 86 inches wide, so that's not going to work. And I can't carry it straight up and down through the doorway either because it's 86 inches high and the doorway is only 80 inches high. So what most of us would think to do is if we can tilt it. Okay, so that's what we're going to be looking at doing with this to see if we have enough room to tilt that tabletop to get through. So what do I know? Well, I know I have a rectangular door, and I know that a rectangle has 90-degree angles. Okay, so because it has 90-degree angles, anything that has 90-degree angles, I can use the Pythagorean Theorem. I'm going to write PT for Pythagorean Theorem to find the distance of the door. Okay, so what is it that we're needing to know? We're needing a diagonal distance. And that diagonal distance needs to be greater than 86 inches, right? Okay, so let's go ahead and figure out what we've got. My rectangular door has a 90-degree angle. Across from our 90-degree angle is our hypotenuse, the longest side. All right, so I'm going to designate A as 80, B as 36, and C is what we're going to try to find. So we'll take 80 and we'll square it. We'll add 36 and square it, and we're going to try to find out what C squared is. So when I take in my calculator 80 squared plus 36 squared, make sure you hit the equal button and you'll get this really big number. Okay, and that we know that number is too large to be the diagonal distance of the door, and that's because it's squared. So as I asked someone in second period today, or third period today, what's the opposite of squaring something? And he said unsquaring. So what button do we use to unsquare something? It's called the square root button. So the opposite of squaring something is to square root it. So the square root of C squared is C, and the square root of 7,696 is approximately, once we round, 87.7 inches. Okay, so think about it. Is the doorway long enough if we tilt the table on the diagonal to go through? And the answer is yeah. The table's only 86 inches, and diagonally we have 87.8 inches to get that through. So yes, the table will fit. So you're just using some analytical thinking skills. Okay. All right. So let's take a look at Greg. Greg plays baseball at a field where the baseball diamond is a square, which each side of the square is measuring 90 feet. If the baseball was thrown from home plate to second base, then from second to third, how many feet did the ball travel? Okay, and we're going to round to the nearest 10th. Okay, so again, I got to draw my baseball diamond first, which is what they said, a square, but it's tilted sideways. Okay, It's not really a perfect square, but we'll go with it. We know that this is home base. This would be second. There's first. There's third. All right, so I'm going to try to zoom in on that a little bit. All right, the ball, I'm going to change my color here. The ball is going to be thrown from home base to second base, and then from second base to third base. So we have to find the distance of those two red lines. Well, from second base to third bases, that one's pretty straightforward because it says in the problem that each side of the diamond is 90 feet. So I know that this is 90 feet over here. Okay. So what I have to find is home plate to second base. All right. So I have a square. And what do I know about a square? Well, I know that a square has 90-degree angles. So we can use the Pythagorean Theorem. Okay, to find the distance from home plate to second base. All right, so what we need to find is we need to again find the diagonal distance. And then we need to add to it the distance from second to third base. And again, we already know the distance from second to third. That's 90 feet. So what we need to do is we're looking at this diamond. We cut this square in half, and that created two right triangles. This is C again, so that's what we're trying to do. We also know what the distance from third to home is, and that is going to be another 90 feet. So if we take A, we know A is 90, and B is also 90. Okay, so let's go ahead and try to find out what C would be. So A squared plus B squared is equal to C squared. So when I, in my calculator, 90 squared plus 90 squared is going to be 16,200 is equal to C squared. Again, the opposite of squaring something is to square root it. And that gives me approximately 127.3. Okay, and the last part is that's how much it traveled from home base to second, but then we also have to include the 90 feet that it traveled from second to third. And that's going to give us 217.3 feet. Okay, so again, think about it. Is there anything new that we learned? No, you just kind of have to process everything and think about what you're doing and apply the Pythagorean Theorem. Okay, so on part 3, hold on, I'm going to shut the door. Sorry, the cleaning staff just came in. All right, so Melissa wants to put a ribbon border around a sign in her classroom, and it is shaped like a triangle. Okay. Excuse me. And the ribbon is going to cost 82 cents per foot. But first we need to find out how many feet she needs. We know that one side is 6 feet, another side is 8 feet. How much is this last side? Well, again, we have our right angle right here. So what we're trying to find is this side, and that is going to be C. So we know that A is 6 feet, B is 8 feet, and C is our mystery. That's what we're trying to find. All right, so go ahead and apply your Pythagorean Theorem. Okay, and I've got 36 plus 64 is equal to C squared, or that gives me 100. And again, we've got to find the square root of it. So C is equal to 10 feet. Okay, sorry if I'm going too fast. I'll slow down real quick. Okay, so how many feet of ribbon does she have to purchase? Well, she's got 6 feet this way, 8 more feet this way, and 10 feet this way. So 6 plus 8 plus 10 is a total of 24 feet of ribbon. Okay, so you take the 24 feet, I'm recording, take the 24 feet, multiply it by 0.82, and what would you get? Okay, so when you calculate that out, you're going to get $19.68. Okay, so 24 feet of ribbon times 82 cents a foot is going to give you $19.68. Okay, all right, moving on. We have an isosceles triangle below, and each of the congruent sides measure 13 meters. So this side over here is congruent to this side over here. Okay, but I hope that you know that you can only use the Pythagorean theorem with a right triangle. An isosceles triangle is not a right triangle. But what you can see is that we are trying to find the height of the triangle, and the height cuts that isosceles triangle into two right triangles. So we're just going to focus over here on the blue part of the triangle. Okay, we have the right angle, and across from the right angle is C. So I know that C is going to be 13 meters. Okay, now it does say in the problem that if the base of the triangle is 10 meters, what's the height of the triangle? That means this entire part down here is 10 meters. But we're only looking at the right side of the triangle. We're only looking at this part of the triangle right here. Okay, so let me kind of get that out of my way. So if the entire part is 10 centimeters, then, or meters, I'm sorry, then the right side is just 5 meters. Okay, so A is going to be the height. We don't know what A is. In fact, they called it X, so I'm actually going to put an X there. And we know that B is equal to 5. So let's do our formula. A squared plus B squared is equal to C squared. So we said A is X, so that's going to be X squared. I know that's a little bit confusing. Okay, oops, I kind of went ahead and squared that one there. I didn't mean to do that. In fact, let me go ahead and fix it. Okay, so that's X squared plus 25 is equal to 169. Well, when I subtract that on each side to get the X squared all by itself, I'm left with X squared is equal to 144. Again, I need the height, and I know that it can't be any larger than 13 because 13 is C. So I'm going to find the square root, and that's going to give me 12 meters. Okay. All right. I feel like number 5 is a little bit easier than that last one. We have a square sandbox in Trisha's yard, and it has an area of 81 square feet. That means all this is 81 square feet. Well, what's your formula to find the area of a square? Well, you take one side times another side, and you get the side squared. Okay? So what we have is we know that the area is 81 square feet. All right? So I know that S2 is 81 square feet. But I need to find out what one side is, because in order to find this diagonal right here, I need to know what this side is and what this side is. Okay, so if the whole area, side times side, is 81, then what is just one side? Find the square root, so we know that we have 9. Okay, so that's 9, that's 9. So A squared, and then here's your right angle right here. And we're trying to find C again. So A squared plus B squared is equal to C squared. So we have 9 squared plus 9 squared is equal to C squared. Okay. And 9 squared plus 9 squared, let me go ahead and calculate that out. Is 162 equals C squared, and the square root of 162 is approximately 12.7 feet. Okay, moving on to the next one. Okay, and if I'm going too fast and you need to pause the video, you can pause the video. Okay, so number 6, To walk to her friend's house, Julie normally walks 63 yards north and 16 yards east. Okay, so how far is she walking? That would be a total distance of 63 plus 16. So she is walking a total distance of 79 yards. Okay. We want to know how many yards shorter would it be if she took the diagonal shortcut. So let's find out what the diagonal shortcut would be. So here's our right angle. We're trying to find C again. So 16 squared plus 63 squared is equal to x squared or c squared. I think I want to keep it as c. Okay, so 16 squared plus 63 squared is 4,225. Find the square root of that, and I get 65 yards. Okay, so this is 65 yards. That's not what the question's asking. So a lot of us would want to put 65 yards right here. And again, that's not what the question says. The question says, how many yards shorter would it be if Julie took the diagonal shortcut? Well, the way that she walks generally is 79 yards. If she goes 65 yards instead, you're going to have to subtract it. So that means it's going to be 14 yards shorter. Okay, so 14 yards is your answer. All right, getting closer to the finish. Okay, now this one is a little trickier because we're dealing with perimeter and area, because you have the perimeter of square 3 is 36 units. Remember, perimeter is all the way around. So if you're going all the way around and it gives you 36, and a square has 4 equal sides, should be able to take 36 and divide it by 4, and I'm going to get 9. So my distance all the way around this square is 9. The perimeter of square 2 is 48, so all the way around would equal to 48. So how much is one side? So I'm going to take 48, divide that by 4, and I'll get 12. So over here, this distance is 12. And then it wants to know what's the area of square 1. So first of all, let's go ahead and do some calculations. We're going to have to find the side of square 1 first. So that's going to be C. So we've got 9 squared plus 12 squared is equal to C squared. All right, so 9 squared plus 12 squared is equal to 225. Okay, that's C squared. Notice it says what is the area of C squared, okay, or what is the area of square 1? Well, we know area is length times width, okay, and anytime that we have something squared, you can think of it as area. So this is actually our answer, 225 square units. Okay, if you did that and if you went ahead and square rooted it and you got C is equal to 15, then you would know that this side is 15, and then you would have to multiply to get area. You have to do length times width, so you would have to multiply 15 times 15 again, which would give you 25 square units. Okay, that one was a little bit tricky. All right, so again, when you're dealing with these squares, the square is an area. So if you're dealing with a square and they're giving you something in square units, like this answer, that's all you have to write down there. Okay, all right, last question. Lincoln is building a wooden garage door in the shape of a rectangle. So we know rectangles have 90 degrees. It has a width of 16 feet, okay, and a height of 8 feet. All right, he's going to place 2 wooden boards in the shape of an X on the door. How many feet of materials will he need? Well, what we're going to do first is we're going to find the diagonal length of this one right here. Okay, so I'm going to put my little right angle there, and we're just going to look. We're going to have to find that piece over there. All right, so I'm going to do 8 squared plus 16 squared is equal to C squared. So 8 squared plus 16 squared is equal to 320. Okay, and the square root of that is going to be about 17.9 feet. Okay, so the length of that diagonal, if I was going to put a board on there, I would need a board that would be 17.9 feet, or right at 18. But I'm going to do the boards in an X. So this over here is also an 18 by, or 8 by 16 square. So I just need to take that 17.9 feet, and I need to multiply it by 2 because I'm going to have 2 boards. So when I multiply that by 2, I'm going to get about 35.8 feet. All right, so to kind of summarize all of this, we are still using the Pythagorean Theorem, but we're just going to have to do something else with it. Are we going to have to add something? Are we going to have to subtract something? Are we going to have to find the square root? It's not an easy unit, but if you take your time with it, or it's not an easy lesson, but if you take your time with it, you shouldn't have too much trouble. All right. Thank you, and I will see you. Find us if you need any help.